All right, we have our last two examples. So this expression here, we have four terms. So I think the best way to, obviously, when you think about four terms, if there's no GCF, which there's not, we need to factor by grouping. So I'm going to factor out the GCF of these first two terms only, which is secant x, and that would be 4 cosine squared of x minus 3. And over here, I can factor out a 2 as in a positive 2, and I'm left with 4 cosine squared of x minus 3. So therefore, this factors into 4 cosine squared of x minus 3 times the quantity of the secant of x plus 2. So factoring obviously is important because now we can basically look at both individual factors. So I think by now you probably know I need to set each one of these equal to 0. So in reality, we are solving the cosine squared of x equals positive 3/4, and when will the secant of x equal negative 2? So if I square root both sides, I'm going to be asking myself, when will the cosine of x equals positive or negative radical 3 over 2? And when, well, if the secant of x equals negative half, that means when will the cosine of x equal negative 1/2? So really, once again, we're not using our calculator, so if you still need to look at that picture of the unit circle, but we actually have 6 answers. So when will that cosine of x equal positive or negative radical 3 over halves? That's going to be at pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. And when will the cosine of x equals negative 1/2? That happens at 2 pi over 3 and 4 pi over 3. So that's where we're getting 6 answers. Remember, there are infinitely many answers, but we're only looking from our range of 0 to 2 pi. Okay, and then last but not least, we have number 6. And so this is going to end up having 3 terms. So we have, I'm going to get everything on one side. Oh, I'm sorry, this is 4 terms. What am I thinking? So I'm just moving everything over to the left. So once again, you're going to want to factor this by grouping. Some of you are getting, I should say cosecant. Cosecant, what am I doing? Of x. Most of you are getting really good at factoring by grouping. I can do this one out for you, maybe if we need to zoom. But if you did this correctly, you should have found that this factors into the cosecant of x minus 2 times the cosecant squared of x minus 1. Now, you're not done factoring, believe it or not, because this factor right here is a difference of squares. So if you didn't catch that, be careful. So we actually have the cosecant of x minus 2 times the cosecant, why do I keep doing that? The cosecant of, oh my goodness, sorry, I have to erase this. It's going to drive me crazy. Come on, eraser. No, I'm wasting your time. Okay, I'm just going to write over it. Sorry. Oh my gosh, now my pen won't work. All right, the cosecant of x plus 1 times the cosecant of x minus 1. So remember, this branched off and factored into those two. So we have 3 binomial factors. So we have to solve basically 3 equations. So when will the cosecant of x equal 2? Or when will the cosecant of x equal negative 1? or when will the cosecant of x equals positive 1? And to just kind of remind you, luckily they're all cosecants. So we're asking ourselves, when will the sine of x equal positive 1/2? When will the sine of x equal negative 1? And when the sine of x equal positive 1? So we end up with, let's see, the sine of x equals 1/2. Well, that happens at pi over 6 and 5 pi over 6. The sine of x equals negative 1. That only happens at 3 pi over 2, because we're looking for that y coordinate, that negative 1, 0. And the sine of x equals positive 1, that only happens at pi over 2. So we end up with 4 answers. So they're pi over 6, 5 pi over 6, 3 pi over 2, and pi over 2. And that's it. Okay? So now you hopefully can be ready to solve by factoring and then the basic algebra methods that we did in part 1. All right. Thank you.